The Earth's surface is not flat but consists of slopes of various degrees, angles and shape. The slope appears to be stable, static or unchanging, especially in the mountainous areas. In fact, it is not so. The slope is getting modified due to transfer of weathered material over the slopes from time to time due to the force of gravity. From the environmental perspective, in the mountainous or steeply sloping areas, it is emerging as a potential natural hazard. From the geomorphic or geographer's perspective, it is considered as a denudational process which is responsible for lowering the height of the landforms. Looking at the terminology, that is mass vesting, the question that arouses our inquisitiveness is, what is the concept of mass vesting? In what way it is related to geography, and so on. Keeping in view this perspective in mind, the main objectives of this lesson are to understand the concept and mechanism of mass vesting, to analyze the factors responsible for mass vesting, to study various types of mass movements. Disintegrated and broken or fragmental materials formed due to the mechanism of weathering processes are called as rock vest. The movement of the rock vest down the hill slope is called as mass movement of rock vest. Mass movement is the detachment and downslope transport of geomaterials like soil and rock material under the influence of gravity. Mass movement is accelerated by the presence of water, ice and air. Mass movement includes both detachment of the rock materials and their downslope movement. The collective term for gravitational and downslope movement of weathered debris is called as mass vesting. Gravity is the sole important force in the mass vesting. Mass movement of rock vest includes the mechanism of detachment of rock materials through different weathering processes and en bloc downslope transport of weathered debris by gravity force without any medium of transport. The rock debris coming through the mass movement is deposited at the foothill zones as scree or talus. The deposits of large boulders in conical shape are called as talus cone. It is thus apparent that the most significant factor of mass vesting is gravity force. Earth's physical landscape is not flat but made up of slopes of different degrees, forms and shapes. Some of the slopes are concave, whereas some slopes have convex in nature. Some slopes are barren and some are covered with natural vegetation. The weathered rock debris transfers over the slopes from time to time due to the force of gravity. There are several activating causes that precede mass movements. They are removal of support from below to geomaterials above through the natural or artificial means, increase in gradient and height of the slopes, overloading through the addition of materials naturally or by artificial filling, overloading due to heavy rainfall, saturation and lubrication of slope material, then removal of materials or load from original slope surfaces, occurrence of earthquakes, excessive natural seepage, indiscriminate removal of natural vegetation, then structure of the rock, then weak unconsolidated materials. The rate of mass vesting depends upon a number of factors. Slope gradient is the most important factor in mass movement. Steeper the slope, faster will be the rate of the removal of material under the influence of gravity. Earth's potential energy is proportional to the height and relief. Slope gradient is also an energy gradient governing the rate of conversion of potential energy to kinetic energy. High geopotential energy is available for mass vesting in landscape with large relief and steep slope. Structure and composition of rocks are also critical factors in the rate of mass movement. Materials such as sand, schist, gravel, shale, etc. are easy to shear and they are more susceptible to the process like fall, slide, flow, creep, etc. Presence of joints, fault planes, cleavages, etc. may also facilitate movement of material. Changes in the environmental conditions such as climatic factors and vegetative coverage also influence the rate of mass movement. Although it is not necessary requirement, water plays an important role in mass vesting. Presence of water reduces the shearing strength of the material. It acts as lubricant, thus making them move more readily downslope. That is why rapid mass movement often takes place following heavy rains or melting of snow. Downslope movement occurs when gravitational driving force exceeds frictional resistance from the material resting on the slope. The main driving force responsible for the mass movement is gravity. Gravity is the force that acts everywhere on the Earth's surface, pulling everything in a direction towards the center of the Earth. On a flat surface, the driving force of gravity acts downward. As long as the material remains on the flat surface, it will not move under the force of gravity. Weathering generally reduces the shearing strength of the rock, thus making them more susceptible to movements under gravity. Slope stability is based on the interplay between two types of forces, the driving force and the resisting force. The driving force promotes the downslope movement of the material, whereas the resisting force deters the movement. The main driving force in most of the mass movement is gravity. The resisting force is the material's shear strength. Shear strength is a function of cohesion, that is, ability of the particles to attract and hold each together, and internal friction, that is frictional between grains within the material. Mass moves over the hill slope when the shear stress exceeds resistance to shearing. Resisting forces act opposite direction to driving forces. The resistance to the downslope movement is dependent upon shear strength of the slope material. When driving forces overcome resisting forces, the slope becomes unstable and results in mass vesting. Water plays a key role in producing slope failure. It erodes the base of the slope by removing the support. It can also increase the driving force by loading or adding to the total mass and therefore reducing resisting forces. Weathering, mass vesting and erosion, all the three are exogenetic processes covered under the general term denudation. The word denude means to strip off or uncover. All these processes are responsible for lowering the relief. Weathering processes are not only responsible for breaking down the rocks into smaller fragments, but also preparing the material for mass vesting and erosion. Movement of material downslope under the influence of gravity is called as mass movement or mass wasting. Mass wasting includes variety of gravity-induced movements of slow material. Mass movement does not involve the movement of material directly by a transporting medium such as running water. Weathering is an in situ and static process, whereas erosion is a dynamic process. Erosion is the denudation process which wears away the land surface by the mechanical action of weathered debris which is being transported by the various agents of erosion like river, glaciers, wind, etc. Mass wasting thus combines elements of both weathering and erosion, but occupies an intermediate position separating the two processes. Mass movements are important part of erosional processes as it moves the weathered material from the higher elevations towards the lower elevation, where transporting agents like running water or river, glaciers can pick up the material and move. Mass movement is transitional between weathering and erosion, involving transport of surface materials by some geomorphic agent or medium. The main processes or mechanism in mass wasting are fall, slides, creep and flows. Fall of earth materials from very steep slopes like scarps and cliffs. Instantaneous fall of weathered material including large blocks from the steep slope or earthen material from the steep and cliffed valley sides of stream under the influence of gravity is called as fall. The size of rock fragments depends upon the size and pattern of rock joints. This type of movement involves vertical displacement of material without water. The velocity of fall is greatest of all other type of mass movements. On the basis of materials, fall is further categorized as rock fall, debris fall and earth fall. Fall is very important process in the vertical movement. Then slides. According to A.L. Bloom, slide is the process of mass wasting wherein a mass or a rock or weathered debris moves downhill along discrete shear surfaces is defined as slide. Slides involve downslope displacement of both types of material, that is weathered material and soil. Slides are controlled by some controlling factors such as nature of slope, moderate lubrication by water, earth tremors, steeply inclined rock beds. Slides are frequent in certain locations having favorable conditions like steep hill slope, fault scraps, rejuvenated valleys, degraded hills and mountains due to deforestation, etc. Generally, slides are often known as landslides, which are most significant of all the types of mass movements. On the basis of nature of materials, direction and rate of movement of the slides are known by different types as slump, debris slide, rock slide, etc. Creep. Creep is a very slow and imperceptible downslope movement of materials, which is called as colluviums. On the basis of materials involved in such movement, creep is divided as soil creep or rock creep. The rate of materials under creep is so slow that it becomes practically difficult for the observer to notice it. Creep is a type of slow movement which can occur on moderately steep and soil covered slope. The movement of the material is very slow and not noticeable. The material involved in mass vesting can be soil or rock debris, depending on the type of material involved. Several types of creeps can be identified as soil creep, talus creep, rock creep, rock glacial creep, and solidification. Flow. Diagonal downslope movement of the rock fragments and soils along the sliding plane with enough water is called as flow. Flow involves downslope rapid movement of the rock debris or soils saturated with water like viscous fluid. Dry flows in sand and silt are known, but most of the flows are saturated with water. Rates of movements in the flows are greater than creep but range from imperceptibly slow to very rapid movement, as in case of mud flow. Flows can be very slow or can be exceedingly fast. Mass vesting implies a variety of movements. Several attempts have been made to evolve a classification of these movements. Mass movements are generally classified on the basis of A. Direction of movement, B. Rate of movement, and water content. Based on the direction of mass movements of rock waste down the slope may be classified as vertical movement. Vertical movement is further divided into rock fall, collapse, and earth fall. Lateral movement is subclassified as block slide, spread, cambering, and sukang. Diagonal movement. Diagonal movement is divided into soil creep, rock creep, talus creep, rock slide, debris slide, slump, debris flow, mud flow, solidification, avalanches. Based on the movement and water content, mass movements are classified into two types: slow movement and rapid flowage or movement. Slow flowage of rock waste and weathering debris. Partial saturation of rock debris is required for such type of mass movement, and moderate quantity of water is needed as lubricating and stimulating agent. Rock creep, soil creep, solifluction are typical examples of this type. Rapid flowage of weather debris. Sufficient quantity of water is needed as lubricating agent. Earth flow, mud flow, etc. are representative of this type of mass movement. Sharp has recognized four major classes of mass vesting, which are designated as A. Slow flowage, B. Rapid flowage, C. Landslides, and D. Subsidence. These major classes are subclassified into 14 types. Slow flowage. Slow flowage is further classified into soil creep, talus creep, rock glacier creep, and solifluction. Rapid flowing mass vesting type includes earth flow, mud flow, debris avalanche. Landslides as a mass vesting type is further divided into slump, debris slide, debris fall, rock slide, and rock fall. Subsidence as a mass vesting category has no further subdivisions. In slow movements of rock waste, partial saturation of rock debris is required and some quantity of water is needed as lubricating or stimulating agent. Rock creep, soil creep, solidification are typical examples of this type. In slow flowage, the movement of the materials is extremely slow and imperceptible. Materials involved can be in the form of soil or rock debris. Soil creep. The imperceptible but continuous movement of soil downslope in response to gravity is known as soil creep. As the soil creep is an imperceptible slow process, it cannot be observed when actually in process. However, the effect of creep can be visualized or seen through indirect observations like leaned or tilted trees or fence or telephone poles. The causative factor for soil creep includes splash rains, alternate expansion and contraction of surface materials caused by freezing and thawing or wetting and drying by daily variations in the temperature or even by grazing livestock or digging animals. Soil creep occurs under all type of climates where there is a slope gradient. Talus creep. Talus or scree is one of the conspicuous products of weathering of cliff, hill and mountain slides. Talus is the accumulation of weathered rock waste below the cliff or the rock. With time, successive rock falls and loose rock waste that accumulates at the base of the slope is called as talus. Talus is composed mainly of relatively large size weathered material. Talus creep, especially rapid, where there is a frequent freeze and thaw activity. Rock creep. According to Sharp, the movement of individual rock blocks downslope is called as rock creep. The detached boulders are often found at considerable distance from the cliff. This type of creep is likely to be most noticeable in rocks like granite with widely spaced joints. The movement of rock fragments across an inclined surface by means of intermittent slips along a plane between the fragments and the ground surface. Such movements are initiated by heating and cooling or by growth of the ice crystals beneath the rock fragments. It is also referred to as surfacial rock creep. Rock glacier creep. Rock glacier creep is the downslope movement of tongues of rock west. Rock glaciers are formed when slow moving glacier ice is covered by rock debris. Solifluction. The term solifluction means slow flowage. Solifluction involves slow downslope flowing soil mass of fine grained rock debris saturated or lubricated with water. This form of mass vesting is common to the periglacial regions which are underlain by permafrost conditions. This can be considered as a form of a creep in which unconsolidated water saturated material slowly moves downslope. The surface layer above the permafrost thaws in summer and freezes in winter. The melted water during the summer cannot percolate into the subsurface layer due to the frozen conditions of the subsurface layers. As a consequence, the spaces between the particles of the surface layer becomes saturated. When the upper portion gets saturated and when the lower parts are impervious to water percolation due to frozen conditions, flowing occurs in the upper part. The movement of material is erratic and irregular. We have seen that mass movement is the transfer of mass or rock debris down the slope under the direct influence of gravity. Several activating causes precede mass movement, such as increase in slope gradient, occurrence of earthquakes, heavy rainfall and lubrication of slope materials, indiscriminate removal of natural vegetation. The basic processes involved in the mass vesting are fall, creep, slide and flow. Mass movements can be grouped under two major classes as slow movements and rapid movements. The slow movements includes various types of creeps and solifluction. In the next session on mass vesting, we will be dealing in detail about other types of mass movement.